Hello and welcome to Applied Database, COP4708. This is Applied Database 1. We're starting Module 9 and we're doing some more SQL. I'm not going to cover all the SQL in the world. I'm going to cover the stuff that you definitely need to know and know quickly to make your life easy. And also a little bit of concept about things like views and triggers and stored procedures. You're not going to write stored procedures. I'm not going to have you write triggers, but we're going to probably write some views. So what exactly is a view? Well, a view is a table, but it's not really a table. It's a virtual table. What you do is you take other tables and you combine elements of the other tables and you can define them as a view. Then you can use the view very much like it was a table. So a nice thing about the views is that because they're not tables, you can create a view completely on top of a table with view-only access, whereas tables might have read or write access, and that you can share with developers and say, okay, they can't mess up the table because they can't put anything inside of it. It's a view. Well, easiest seen by doing it. One, you got the ability to hide columns. You got the ability to hide rows. The views can actually do some aggregation in functions, which is nice. When you've got multiple tables and you have to link them together, we can hide that syntax from people where they can just instead use a view. Now, in SQL, or actually in transaction SQL or some of the SQL languages like PL SQL, you have the ability to build in functions, your own functions and built-in functions that actually come with SQL. You can layer those in. Now, one of the biggest reasons though is giving that isolation between the table and the user, which oftentimes is an internet user. You know, internet, you type away, and what it does is it runs off to a database, does a SQL query, and pops up the result. Well, you don't see that SQL query, but somewhere along the way, a developer had to actually build code to go out to that database and get stuff back. Most of the time, you can build that on top of one or two things, views or stored procedures. And it gives you a lot more control of the database when you do that. Also, we're going to look a little bit at triggers, but we're not going to really get caught up in triggers. We will get caught up in creating views and assigning permissions to views. So let's take a look at what actually happens here. So we had from the previous examples some tables that contained actually more than, like the table that we've got, the customer table, has more than the last name and the first name, but we can create a view that has only first name and last name. Now, note here that we've actually got select last name as customer last name. Well, in any select statement, we have the ability to define the name of the column to be different from the name of the column of the table where we got it from. If we actually wanted to read customer space last space name, you can actually put that select, that can be a string. So you can actually have it actually read, nice. But notice that when you created the view, we created the view as an actual select statement. So the view, in this case, is simply the result of what you would have gotten from a SQL select. That's what it does. And the select is just pulling two columns from the customer table, last name and first name. Then, when you want to actually see the results of just the customer, you can do select star, which is all records from the view, customer name view. Notice that, and the syntax should make logical sense. Create view, the name of the view as, and then this is what actually makes up the view. The view is the result of running this specific select statement. Then, when you want to actually see the view, it's select star from the view, and then you can use the order by, and you can order it by the last name or the first name. That's it. Pretty straightforward stuff. Now, you can make views that can actually be updated. You can use a view as a way to write access to a table. Okay. Now, you may or may not do this. Okay. There are places to do this, but when we're actually getting to the stage where we're going to go ahead and insert data, and views don't really work with insert, or update data, we've actually got a better way to do this, especially with Oracle and with SQL Server, also with most databases. Okay, it's nice. Okay, now there are some rules, and the rules on making updatable views should make sense. Okay, they'll make more sense when we actually get into doing some updates with views and say, why can't we do that? But when you're putting data in, there is a better way. And that would be to actually create some code that handles that. Now, in Oracle, the language for doing that is PL/SQL. Procedural language with SQL. SQL is not a procedural language. Okay, it's not. It's a declarative language. You say, do this, but it's not this big algorithm that you're giving it. You're saying, go to the database and find the records that match what I just told you. It doesn't say, go to the database, find the first row, and keep going through the rows until you reach the end of it. That's all built into SQL. You declare what you want it to do, and it does it. However, there are times when you really do want to do procedural programming in SQL. One of the reasons of this is simple. When you're writing code, and you will write code to access databases, and you might be writing the code in Java or C# or JavaScript or PHP or Python, all those languages, those are procedural languages. And you get used to object-oriented programming and procedural programming. You oftentimes need the ability to do that in SQL too, or inside the database. The other nice thing about that, and these are called stored procedures, it encapsulates a good chunk of the logic that goes with the database in the database, because stored procedures are stored in the database. So one of the pieces of stored procedure coding, which you can do inside of a stored procedure, or you can do in just basic SQL code. You can put this right there into a SQL window and it will work. You can declare a cursor, and the cursor can actually contain the results of a query. What the cursor does, however, is it actually keeps track of it on a line-by-line basis. So what you do is you say, we're going to declare this cursor. Okay, and then when you can open the cursor and you can say, okay, let's start on the first row and just loop through row after row after row after row and do something. So it has the ability to loop through individual sets of rows of the table and actually have some sort of action that's associated with it. Oftentimes we build these cursors and then we simply embed them inside of a SQL stored procedure, but they do also work in any SQL window. You can actually declare cursors and execute this piece. Notice, however, that this is procedural. This little first line is declarative. You declare the cursor. That's not really the declarative part. You can always declare variables in procedural languages. This part, the select star from customer, is the declarative part. You're saying, go out and get everything and bring it back, stick it in this cursor. That cursor is a variable, and now I can go through each one of those line by line. So, Stored procedures, also called stored modules, also called persistent stored modules, also called procedural language, SQL language stored modules, also called SQL language persistent stored procedures. Okay, they're all the same thing. Now, there is the difference between a stored procedure and a stored function. They look almost exactly the same. But there are nuances to the differences. We're not going to cover them. They get covered in Database 2. If you take Database 2 from me, you'll learn all about those things and get to play with them. Now, there's some specifics to the languages in specific databases that are the languages that we write these stored procedures in. They look almost the same, but they're not exactly the same. So in Microsoft SQL Server, we call it T-SQL. At Oracle, we call it PL-SQL. Okay, and even MySQL, you've got a specific language for that. It's essentially way behind the other languages. Also, triggers. My first advice for triggers is if you cannot do triggers, don't. And there's a reason for that. A trigger is something that happens when something else happens. So a specific event occurring on a table or a view can actually be picked up by a trigger. And then that trigger, which is defined separately, you say create trigger, and you say this is what I want the trigger to do. Then that trigger, which is actually declared to happen when some other event happens, that event happens and the trigger happens. What happens is, however, and there's a lot happening here, as you can see, is that oftentimes with triggers, you might have a trigger that triggers something to happen, which triggers another trigger, and they're very challenging to take care of. Also, the fact that because the trigger is a totally separate thing, you may not even be aware of a trigger existing on a specific action that occurs. And when I talk about an action that occurs, I'm talking about you either inserted to the database, you updated the database, you deleted a row from the database, and you have three types: before instead of and after. So combine those three. Now you know that you've got 9 different types of triggers. So before an insert, that means if you actually do an insert statement, before an insert of this type, do this instead. So what do they look like? Well, triggers, and when we say triggers when triggers get executed, we actually say the trigger gets fired because it's an event that causes it to occur. So you may be replacing values, you may be checking on specific conditions, you may pull default values. It's a lot easier way to do most of these. You may use it to enforce some constraints that you have. Okay, again, all of those have other ways to do them. So here is an example of a trigger. And the creation of a trigger, this is just the code. I will go through it a little bit here. But you say create trigger trans asking price initial value after insert on trans. So basically what you're saying is kick off this trigger after somebody inserts something into the trans table. Then the trigger's got to have certain things that are variables, and in this case you can see that so you're declaring some specific variables. Then begin. And this is the set of code, this is the actual procedural code that would get executed after an insert into the trans table. Okay, so what it first does is it selects a count from the trans table where you're looking at the work ID and checking to see if it's equal to the new work ID, so the one in the table is there. If it's 1, okay, you're going to do one variable. That basically means that work ID exists already in the trans table. If it's greater than 1, you're going to do something else. In this case, it actually does a select, and it does a calculation, and it sets the asking price to be difference. Then you've got an else, which is the if, and then the end if change. What that is doing is it's encapsulating a specific set of business logic into the table itself. Same thing can occur in this case when you're looking at an employee. Instead of delete the employee, okay, this one would be used to say that if the employee has a, we can't delete the last employee. So if the row count is 1, then we don't delete the employee. And if the row count is greater than 1, we do delete the employee. And it's an instead of. Instead of deleting on the employee, we check to see if the employee is the last employee. And if it is, we don't delete them. Otherwise, we do. Okay? It is triggered. It happens when something else happens. Now, what's a better way to deal with this? Because, again, making something happen automatically when something happens, there is a good piece of business logic here, but stored procedures are actually a better way to deal with this. And a stored procedure, you can say, instead of allowing a delete on a table, we'll have a stored procedure that handles all deletions and encapsulates all the business logic. So you never do a direct delete. In many of the programs that I've written, and I've written many programs, especially ones that are client-server database based, I do not allow triggers whatsoever. And the only access to the database is through either a view or a stored procedure. Nobody touches the tables directly except for the database administrator. That is just a rule that we put into place. Why? Because the database administrator is the one person who is responsible for that data. They will build how anybody else accesses the data. So all the code that you saw in those previous examples can be encapsulated inside of a stored procedure. And all stored procedures can be called by pretty much all languages. Now that I say, okay, that you've got the ability to write it in PL SQL or Transact SQL for the two major databases, they look very much the same. Stored procedures. For one, they're stored in the database. They're right there. You can get to them. So the logic is where the database is. Another one is that, okay, by only having one thing occur, boom, network traffic goes down. That's never really a major problem. SQL code has the ability to be optimized. And COP4709, I'm going to just make a plug for the next database. You'll learn how to do that. Okay. It really lets the database people be database people and the programmers on the outside be programmers. And you don't have to become experts in both because, trust me, messing up the data is one of the bad things that you can do. So what would procedure look like? Create procedure. Okay, work, add work transaction. So here's a good one. Okay, in this, and I usually begin all my stored procedures with SP underscore and then the name of it. Now, one way to do this is to have a naming convention for your stored procedures. So you could say SP underscore work. That would be the table that you would be adding to. And then the next would be add transaction. I wouldn't call it work, add work transaction because for one, the work is redundant. And the other one is you want to know it's a stored procedure. So create procedure SP underscore work underscore add transaction. That actually is a very logical name. Most of the time, the database administrators will have, they look cryptic to people from the outside, but when you're a programmer, they make perfect sense. And so what does this do? Okay, it goes in and it says, first, you pass it all the information you pass to the stored procedure. And this will be from whatever in the outside is accessing. It could be a form on the internet where all this information is there. What does it do? It goes to first to say, hey, is this a valid artist? Because if it's not a valid artist, we're not going to go ahead and insert this. because we have to have a valid artist to insert a work to the artist. If it is a valid artist, go ahead and do the insertion. Okay, there. Straightforward stuff. Okay, you're not writing stored procedures in this class. You write lots of stored procedures in the next class. Okay, and by then you'll be pretty comfortable with writing stored procedures. I never had anybody have any issues with it. Okay, and there's the end of that last stored procedure if you really want to see it. And I know everybody's kind of like, look at the screen, what does that say? Get my glass, wait, hang on here, I gotta read this. Okay, there we go, I can see it. Yep, that looks like a good one. And yeah, fun. So, triggers versus stored procedures. I'm just going to tell you, try not to use triggers. And it's that fourth one down on that trigger line. Triggers can be triggered on inserts, updates, and deletes. Okay? Triggers can also include insert, updates, and deletes, meaning that a trigger could trigger another trigger. That almost always leads to bad things. Stored procedure, okay, you just manage all of it inside of one procedure. Now, we're going to look at some things that you kind of need to know. First, you've got primary keys, and you want the primary key values to always be unique. And what you probably want to do is you want that primary key value to just increment every time somebody inserts a new value. There's ways to do that. One is, in Oracle, create a sequence. Okay, this is how you do it. You create a sequence, and then you can always go to the sequence and get the next value. So you always get that. That's an Oracle way to do it. And it's a good way to ensure that the numerical values are unique. In SQL Server, it's quite easy. You just declare a column to be an identity, and every time something gets inserted into that column, it's going to get incremented. You saw this in some previous stuff here. Select count. Select count, and star is see it says column name. Well, star can be that. Basically, you want to count how many records exist. That is common. If you want to know if something is in the database, you say select count star from table where primary key equals a specific value, and voila, you can say if it equals 1, that means it already is in the database. If it is equal to 0, it means it doesn't. Some really useful stuff, order by. When you do a select statement, you're going to get results back. Most of the time you want those results in a specific order. Order by will do that. Of course, you also want to declare the conditions that you get from the select. So the where is kind of important too. Okay? And if you have a where, that means you've also got to have some sort of condition. And if you have conditions, you have to have 2 things to go with those conditions. There's actually more than 2, but we're going to talk about 2. You can have and, okay, where condition and condition and condition, ands. You can have ors, condition or condition or condition. And of course, if you have ands and ors, you also need to have a good old not. Okay, this is not a joke. You want the not with your and ors. Okay, I know it's a moon somewhere in Star Wars. Guess what? No, that's Endor. Oh well. Anyway. Jokes aside, where can I go to learn more about this? I have my favorite place, which I will refer you to because there's way more to SQL than we're just going to cover. All the thousands of things that you can do with SQL in this class. You're going to cover some of the big stuff, though, and you're going to use the big stuff. But where is the good stuff at? This is my favorite tutorial on SQL. One, it's very easy to search. It's very easy to understand, and it covers all the different flavors of SQL. It tells you this works in Oracle, but it doesn't work in SQL Server, and this works in PL SQL, but it doesn't work in Oracle, and it's really good about that. Most of the basic SQL works in all of them, so that's at least good news to all of you. Have fun. This is actually pretty cool stuff. I mean, once you start getting to work with data and you know how to manipulate large databases, right now, you're manipulating large databases is kind of limited because you're going to have to insert all the data into your existing databases. But at some point, we're just going to give you a ton of data that's already in the database and let you start doing this fun stuff with it. So that is it for this lecture. This gets you off and running in the SQL world. And at least even the things that you're not going to do, you know that they exist. So you're not going to be like, oh my God, where did that come from? You should have a good understanding of how these guys all work together. Now we get to have some fun. Talk to you later. On out.